In the rapidly evolving world of anti-aging science, one of the most promising and bizarrely underappreciated frontiers may be quietly flowing through your veins: the blood microbiome and its molecular byproducts. Long thought to be sterile, the bloodstream is now emerging as a conduit for microbial metabolites that originate in the gut but act far beyond it. These tiny, often aromatic molecules can influence everything from immune regulation to inflammation, mitochondrial health, and even gene expression. So it's no surprise that a new wave of researchers and biohackers are asking, if these compounds are already altering our biology from within, could we engineer anti-aging supplements to mimic or enhance them? The answer, it seems, is not only yes, but inevitable. At the top of the microbial hit list are indoles, tryptophan-derived molecules produced by gut bacteria like Clostridium, Bacteroides, and Lactobacillus. Once absorbed through the gut lining, indoles like indole 3, propionic acid (IPA) and indole 3, aldehyde (ILD) enter the bloodstream and behave like molecular diplomats, engaging with host receptors such as the aryl hydrocarbon receptor (AHR) and pregnane X receptor (PXR). Their influence spans antioxidant defense, epithelial integrity, inflammation, and even neuroprotection. IPA, in particular, has shown an ability to protect mitochondrial DNA, scavenge free radicals, and maintain blood-brain barrier integrity, all major pillars of longevity science. Now imagine encapsulating a stable form of IPA or its analogs, formulated for precise timed release, possibly combined with a prebiotic or engineered bacterial strain to support in vivo production. Such a supplement wouldn't be another glorified vitamin pill. It would be a synthetic microbial whisper, mimicking the beneficial messages of a healthy gut and delivering them directly through the bloodstream, bypassing the chaos of variable digestion. Then come the short-chain fatty acids, SCFAs, primarily butyrate, propionate, and acetate, produced when gut microbes ferment dietary fiber. Butyrate, the darling of colon health, has systemic reach. It functions as a histone deacetylase (HDAC) inhibitor, meaning it can modulate gene expression, turning up repair programs, silencing inflammatory genes, and even reactivating mitochondrial biogenesis. It also acts as a fuel for colonocytes, supports immune tolerance, and may even suppress age-related cognitive decline by reducing microglial activation. The challenge? Delivering butyrate in a palatable, targeted form. Most oral butyrate smells like Foot Locker and disappears in the stomach. But advanced encapsulation technologies, lipid micelles, or symbiotic formulas, pairing specific probiotics with resistant starches, are making it more feasible to send SCFAs or their precursors into systemic circulation. We're now entering an era where precision-engineered SCFA supplements could act not just on the gut, but directly on the epigenome, immune system, and brain, all without needing to change your entire microbiome first. Beyond indoles and SCFAs, blood also carries lesser-known but intriguing microbial metabolites like phenylpropionates, secondary bile acids, and tryptamine derivatives, each with signaling roles that may affect metabolism, mood, and inflammation. These compounds interact with host cell receptors, modulate insulin sensitivity, and even trigger cellular stress responses that resemble caloric restriction or fasting, a holy grail in longevity research. The idea of formulating postbiotic cocktails that mimic the signaling profile of a youthful, fiber-rich, low-inflammatory gut is quickly gaining traction. And the most exciting prospect? Personalized blood microbiome supplements. As detection tools get better, through advanced metabolomics and cell-free DNA analysis, researchers can identify your unique circulating microbial fingerprint. Some labs are already exploring how to customize supplement protocols based on your individual microbiome's output, not just its composition. You won't just be taking gut-friendly capsules anymore. You'll be taking blood-optimized nutraceuticals, tuned to enhance or balance specific microbial messages your body is, or isn't, already hearing. In the future, anti-aging protocols may not just involve a probiotic yogurt or a high-fiber salad. They may include designer indole mimetics, targeted DAC-inhibiting SCFA analogs, and synthetic quorum-sensing inhibitors that disrupt pro-inflammatory microbial chatter. You could have a supplement stack that mimics the blood metabolite profile of a 25-year-old marathon runner with perfect gut flora, even if your last jog was in 1997. Of course, none of this comes without caution. Tinkering with microbial signaling is not like taking a multivitamin. These molecules influence multiple organ systems, immune tone, and even the gut-brain axis. The margin for error, especially if used indiscriminately, is real. But with careful design, systems biology, and controlled delivery, these compounds offer a glimpse at a new kind of longevity intervention, one that doesn't just chase symptoms of aging but mimics the molecular signatures of youth. In short, the future of anti-aging supplements may not come from the Amazon rainforest or your grandmother's herb garden. It may come from a bacterial conversation your bloodstream is already having, one that we're finally learning how to translate and, perhaps soon, how to write ourselves.